All right, let's take. You may or may not be done, but let's kind of walk through these. And you don't have an equation. You just have the graph to go off of. So there's nothing to substitute in. So you got to use this graph for all your answers. Find the domain of G. And so you got 1, 2, 3 pieces, but some of you are saying, well, what does it matter? You got an open circle and a closed circle. You need to write the simplest form of the domain, including all the points. So is at 5? Is negative 5 in the domain? Okay. So that would be 1, 2, 3, 4, negative 5. There's a point that has it as an x-coordinate, so it's in the domain. You do not need to break this apart. What would be the easiest way, or what do you think is the easiest way to represent that domain? Okay. Check.
Negative 9 to infinity.
So negative 9, that would be correct. So the domain includes a negative 9, and it goes to infinity because the arrow's on that graph. So everything from negative 9 will be hit. Doesn't matter that it jumps up here. You still use that value.
So even if you broke it apart, would that still be wrong?
Yes, because you want to write it in the simplest form. Okay. So you would say negative 9 to infinity, and then that's just a much easier way to see it. All right, range. What would be the range of G? Hey, what do you got, Kyle?
Including negative 4 and including 6.
Including negative 4, so like negative 4 to 6, like this?
Yeah.
Okay, now one thing you're saying is every number between negative 4 and 6, but does it hit anything here, any y value? Does it hit 1, 2, negative 3? No, it misses all of those. So negative 4 to 6 ways written, you're saying it's everything. It does hit negative 4, but it only hits that number, right? So write that as a singleton, negative 4. Now here we have to do union. Got to. You can't get around it because otherwise we're saying all those other points are in there. What would be the easiest way to represent the next part? So it jumps up from negative 4 to what? Negative 2. And so it would be negative 2 to 6. It doesn't matter that, you got a gap here because it gets covered with that line. There's nothing covering from negative 4 to 2 on that range. All right, 81. Sometimes this one is a little confusing the first time you see it. You got to look at it. What are you looking for? It says G of negative 4. When you plug in negative 4, what do you get back for your answer? All right, and that's what it's saying. And there's nothing to plug into. Aaron, do you know the answer?
No.
Okay. All right, so go to the x value, negative 4. Is there a point on the line that has x there? Well, this point has the x coordinate of negative 4. What's its y coordinate?
Negative 1.
Negative 1. So when you plug in negative 4, what do we get back?
Negative 1.
That's your answer. Go to the graph, find that point. The y value would be G of negative 4. So it would be negative 1. G of 1. Okay. G of 1. Maddie, what do we get when we plug in 1?
3.
3, because you go here to 1, 3, you get that point. And then G of 3. All right, what's that going to equal when we do that one? Plug that one. That
What about 4?
4. So G of 3 is 4. 1, 2, 3, 1, 2, 3, 4. So that's that point right there. So that's how you read that when you don't have anything to plug into. You should look at your graph, substitute in. 82, absolute value, G of negative 5 minus G of 5. And we want to simplify that. All right, what's G of negative 5 as you take a look at that? Kylie, what do you think?
I got negative 2.
G of negative 5, yes, because you kind of got those 2 points. You got to use the one where it's included. So you got negative 2 minus G of 5, 2, 3, 4, 5, 6, right there. So that's a 5. No, that is 6, right? Negative 2 minus 6 is negative 8, but we're taking the absolute value, so that is 8. All right, 83. G of x equals negative 4. So what do we want? Which value to be negative 4 now? Okay, x or the y?
Y.
We want the y value to be negative 4. Is there more than one point that has a y value of negative 4? Yeah, if you look here, all of these values of a y value -4. So you have to include them all. So the x, you could say, exists in the interval from, what is that, -9 to -5, not including -5. Okay, so any one of those values, you plug it in, you get back a y value -4. All right, look at g of x equals 6, if you haven't gotten to that yet. Danielle, what do you think for g of x equals 6?
That's 6.
6 would be one answer, 3, 4, 5, 6. That would be this point right here.
Oh, 6 to positive.
All right, 6 to, is it 5 or is it 6? 1, 2, 3, 4. The x value is actually 5, that first one. So we want it to be from 5 to positive infinity, because we want to go from this point here. Yep, that is 5. So for all those values get included. All right, so I want to do that one together. Homework, 37 and 47. Let's take a look at those before I give you the answers to the evens. 37. I don't know if it's f of x or g of x. What's, Jack, you got the equation?
F of x equals a -8x plus 7.
A lot of times you're just, first of all, you're looking at what can't be in the domain. Can't divide by 0, can't have a negative underneath the square root. Do I have a fraction? No. Do I have a square root? No. So there's right there. That means everything can be plugged into the equation. So your domain is all real numbers, because there's nothing that can be excluded. Another way to think about it, is there a number that I'll plug in there that I won't get back an answer? No, any number I plug in, you just multiply it by -8, that's 7. Okay, so that one there is all real numbers, negative infinity to infinity. Jack, what's 47?
F of x equals the square root of x squared plus 1 over x.
Okay, we got two things going on. We got a denominator, x. Well, what can x be? The only thing that will make it undefined would be a 0. So x cannot equal 0. Now you got to be careful with this one right here. You really got to look at it first, because a lot of times your first instinct, which is fine, is just go ahead and write it like this. All right, so you say x squared plus 1 has to be greater than or equal to 0. And you're like, well, what if I do this? Some of you do this. But think about this. If I plug in a negative number, do I get back a positive or a negative? Okay, you always get back a positive, right? -3 squared is 9. 9 plus 1 is 10. -2 squared is 4. 4 plus 1 is 5. Can that ever be negative? X squared plus 1. No, it can never be negative, because x squared is always positive, and I'm just adding 1 to it. So you can look at this. Well, x squared will always be greater than or equal to -1. So really, you don't get any additional points we need to throw out from that part. That piece will always be positive. Only thing I need to worry about is 0. That is why the domain is everything but 0. Negative infinity to 0, union 0 to infinity. Okay. So just be careful on that, especially when you get that squared. Look at it really close, and then you might be able to, figure out, will it always be positive or always be negative? All right, your even ones. Okay, do take a look at those, please. And then look at the figure, make sure it matches up. Once you're done, we're going to finish up those notes from yesterday. Academic challenge, Mr. Laverick's room, after school. Those of you who are interested. And there should be several of you interested in here. All right, anything we need to go over? Any additional questions on any other numbers or any of those evens? Doesn't matter. All right, let's finish up those notes. Only thing we're going to talk about here today is that last piece there is evaluating functions. Now you evaluated them with a graph. We're going to evaluate them with a equation. We're going to use the same one for all of them. So let f of x equal 2x squared minus 3x plus 7. All right, f of 5. What's the only thing you do? Plug in 5. That's all you got to do. All right, so now it's going to be 2 times 5 squared minus 3 times 5 plus 7. Now, the only thing, and I just see this every now and then, is there's a tendency to want to multiply 2 times 5 together and then square it. You can't do that. You have to square the 5 first. Why is that? Order of operations. You got to do exponents before multiplication. Do not multiply 2 times 5 first. You got to take 5 squared the way it's written because there's no parentheses around the 2x. You get 25 minus 15 plus 7. So 2 times 25 is 50, minus 15 should be 35, plus 7, I believe, is 42 there. So end up with 42. All right, you plug in -4. See what you get. Tessa, let me know what you get.
Got 51.
51, that's what I got. -4 squared is positive 16 times 2 is 32. -3 times -4 is positive 12. 44 plus 7 is 51. All right, now this next one is really hard. F of M. All right, what's the only thing you need to do? Put an M for X. Okay, it's not really hard. F of M equals 2m squared minus 3m plus 7. Nothing else you can do. Doesn't say solve, it just says find F of M. That just means you substitute M in there. Done. Okay, so no, it is not difficult. But you can plug in variables, you can plug in constants, or you can plug in an expression. So let's take a look at what f of a plus 2 is going to look like. Follow your rule. Everywhere there's an x, what do you substitute in? A plus 2. You plug in that whole thing. So f of a plus 2 is going to be 2 times the quantity a plus 2 squared. So make sure you put that in parentheses with the squared on the outside. Minus 3 times a plus 2 plus 7. Now that a plus 2 squared, you got to FOIL it. So you're going to get 2 times a squared. When you're done FOILing, you'll get 4a. 2 times 2 is plus 4. Distribute your -3. And now go ahead. Distribute your 2 and then combine any like terms. You do want to simplify where you can. So I get 2a squared plus 8a plus 8 minus 3a minus 6 plus 7. And so I get 2a squared plus 5a, positive 2 plus 7 9. So f of a plus 2. So you substitute the expression in, it's still going to be in a quadratic form. All right, last one we're going to do here together. F of x plus h. Same idea, wherever there's an x, replace it with the quantity x plus h. So f of x plus h equals 2 times the quantity x plus h squared minus 3 times x plus h plus 7. All right, we got to FOIL that. I'm going to do that on the side just because this one will come up a lot. And I just want to make sure I'm going to go through it the first time, like do the whole FOIL thing. If you get it the first time, you don't need to like necessarily write it out, but I just want to make sure that you see this. X plus h times x plus h. X times x is x squared. X times h is positive xh. H times x is hx, but you can switch the order to keep it the same. I'm going to make it xh. Then h times h is h squared. These two in the middle will add up to get 2xh. You're going to have to get a middle term. The only time you don't is one's a plus and one's a minus. So we don't have that in this case. So now I'm going to go back over here. F of x plus h equals 2 times x squared plus 2xh plus h squared minus 3x minus 3h plus 7. Oops. Distribute your 2. Look to combine like terms, but are there any? There's not. And then don't worry about rearranging anything. Just distribute the 2. However it ends up is fine. So you got f of x plus h is 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 7. There's no nice way to write that. Just leave it like that, like I said. All right, I want to get done early because I want to give you some time. Okay, you're going to get a worksheet over all of chapter 2, everything we've done. You're going to turn this in physically tomorrow. And I'm going to look at it for correctness, not just completion. Okay, so if you forget how to do something, you're going to have to go back in your notes. So do not submit online. Do not submit. I do. I'll get it. Let me pass this out. There we go.
Yeah, it makes sense.
It's a little archaic, but it works.
How did you get your pictures? I got them from. Oh, shoot. I worked
Thanks.
What's yours?
I'm just kidding.
Yeah.